Welcome to One Chemistry. Always do your best. Now let us see about 100 conversion in organic chemistry. We are seeing it as episodes. This is the 16th episode. If you didn't watch previous episode, I encourage you to go and see. Here we solve 5 problems step by step. Stay tuned. Question number 1. The decalene attached with methyl and a trans hydrogen and OH. Phosphoric acid is given. They ask you to find the products. Products are like where the double bond is forming or ring expansion. Here you have to understand that selective elimination of hydrogen is occurred, which hydrogen leaves. This reaction is E1 reaction, hence the carbocation formation occurs. So first step you are removing H2O, so you are adding the acid, so water is removing. So the planar cation is forming. So the cation formation occur after water elimination. Then there is 3 possibilities, A, B and C. Which hydrogen will leave? A hydrogen or B hydrogen or C hydrogen. Here you should know always CSIR product is forming. Since we are not using any strong base or acid, the only possibility is CSIR elimination, which is a more substituted product. Here you should know that no rearrangement occurs. Why? Because a cation is already tertiary cation or no ring strength. There is nothing, no rearrangement, so only 6-member ring. Here the question of hydrogen elimination. One thing I want to say is the hydrogen stereochemistry doesn't matter here. It's just given to confuse the user. Here you have to know 2 things. One is E1 elimination, cation formation, then the CSIR elimination. CSIR elimination means more substituted product is formed. Then the question number 2, here starting metal is benzene, which is attached with the isobutynyl group, then the group converted into acid. Here they are asking you to guess the reagents. So which are all the reagents? Hydroboration or oxidation, or Wacker oxidation followed by Haber-Form reaction, or Oxymercuration or Demercuration. Voss analysis and Calor-Form reaction. Here they ask you to guess the reagent. Here you have to understand that new carbonyl group is formed and one carbon is less. CC bond becomes COOH. The answer is B. Let us see how. The starting metal is alkene. So here we use the Wacker oxidation. Wacker oxidation normally you convert CC double bond into COCH3. So we are introducing carbonyl there. So CC double bond becomes COCH3. Then Haber-Form reaction. Since there is 3 alpha hydrogen, Haber-Form reaction is possible. So we are using the base and the halogen. So COH group is formed. Here 2-step naming reaction is there. What is the important of that one? CC bond becomes COOH. So it is curious since it is involved Wacker oxidation and Calor-Form reaction. Then the question number 3. Starting metal is conjugated cyclohexanone attached with methyl group. Methyl group is above the plane. Here they given the reagents lithium aluminum hydride, acetic anhydride and pyridine, organometallic reagent copper methyl with solvent. Here they ask you to guess the product. Here you have to know CO reduction is there as well as selective methylation. So you have to know which one is which. The answer is C. Let us see how. The starting metal is ketone, right? Let us rewrite to have our understanding. We rewrite it as chair form. So chair form double bond. So don't miss anything, write properly. The methyl above the plane and the carbonyl group and double bond. Then we are using lithium aluminum hydride. Lithium aluminum hydride, hydrogen is the smaller one. So it's always prefer axial position. It is smaller than OH. So it is always prefer axial position. Then the acetylation happened. So OH become OCOCH3. So acetylation occurs. Then the ring flip occurs. Once the ring flip occurs, the COCH3 become axial one. Why we are writing this one? Because of the easy elimination of CO2. Axial will be the easy elimination, that's why we are writing that. Then we are using the copper methyl. So methyl attacks, the double bond switches, CO2 leaves. Here you have to know why CO2 leaves. Because we cannot stabilize anyway the carbon ion, only CO2 leave and form the neutral one. Here methyl group is little bit bulkier, so it attack from below. So the product is methyl is below and starting middle already having methyl is above. So here CO group is eliminated, methyl attack from bottom. Here you have to learn two things. One thing is elimination always possible in axial position, then only the elimination will be easy. Second thing is always stability is important, that's why CO2 is eliminating. Then the question number 4, starting middle is toluene phenol which is crazole and the reagents are formaldehyde and sodium hydroxide and hydrogen peroxide and sodium hydroxide. Here they ask you to guess the product. The products are mostly focused on COOH introduction or the reduction reaction. Here you have to guess the naming reaction and you have to understand the reagents. This is an interesting one. The starting middle is crazole, so you are using the phenol and NaOH. Everybody know which is the basic reaction, which is Reamer-Tiemann reaction. So orthoaldehyde formation is occurred. So orthoaldehyde is there. You have aldehyde, you have hydrogen peroxide. So what really happened? You have Dakin reaction. So the Dakin reaction occurs. The oxidation happens. The peroxide attacks and the carbon switch to oxygen. So new oxygen inserted between aldehyde and phenyl group. So new oxygen inserted. After the hydrolysis you are getting the alcohol again. Here you should know two things. Why we are following this many steps for this one? Because OH minus is the nucleophilic one. It cannot attack electron richer one. That's why we are going 2 steps to synthesize the dihydroxyphenol. So here Reamer-Tiemann and Dakin reaction involved. Then the question number 5, starting middle is alkene which is deuterated one and the boron we are using and hydrolysis. They ask you to find the product A. Then you are adding the vinyl compound. Then palladium also used as catalyst. They are asking you to find the B. Here the naming reaction involves, you have to guess boron and triple bond and double bond. You have to guess the naming reaction as well as the double bond configuration. The answer is A. Let us see how. The starting middle is deuterated acetylene. This is a Suzuki coupling where boron is added to the triple bond. The boron added to the triple bond in the syn way. Since boron is bulky, there will be always Markovnikov addition, or you can other way it says the negative part added to less number of hydrogen atom or more substituted carbon atom. So boron is attached to third carbon, deuterium attached to second carbon. So it's a syn addition, both are at same way. So the product is kind of trans. Then you are doing a hydrolysis, boric acid will be formed. Then we are using the coupling one. So the coupling we are doing with palladium. So coupling occurs. During the coupling, no change in the any configuration. So the final product occurs which is trans and cis. So the answer is clearly A. Here you have to know two things, Suzuki coupling and the addition reaction of boron in the triple bond is syn addition. That's all from this episode. Thanks for watching. If you have any suggestion, comment below. Stay tuned for next episode.